Good morning to everyone. Myself B. Rajeshwari. I am from ECEB section. Here the subject is EM waves and transmission lines. Here my topic is infinite transmission lines theory and analysis. Branch ECE. Here topic is the infinite transmission lines theory and analysis. What is the introduction of the infinite transmission lines? The infinite transmission lines and characteristics by the characterized by their length, which is a considered infinite for the theoretical analysis. They are used to simplify the study of wave propagations and transmission lines without need of the intermediate conditions. Understanding their behaviors is a crucial applications of the telecommunications and signals and integrity. Here the applications are the telecommunications and signal integrity too. Basic concept in infinite transmission lines can be a thought of the cascade identity small transition line segment. The propagations of the line such as the impedance and propagation constant determine how signals are traveling along the line. The voltages and a current at any point can be expressed using in a telegraph equations. It is described as the relationships to telegraph equations. The telegraphic equations are set of linear differential equations describing a voltage and current along the line. What is the telegraph equation? The equation is the set of linear differential equations describing a voltage and current along the line. This is the solving a differential equation. dy by dx plus y is equals to x, dy by dx plus 2y is equals to 3x. These equations accounts for the lines and the resistances, inductance and capacitance are conducting for the unit length. By solving these equations, one can derive important characteristics such as impedance and phase velocities. Characteristic impedance. The characteristic impedance Z0 of the infinity transmission line, which is defined as a ratio, and voltage and current steady state conditions. It can be calculated using the formula Z0 root L by C, where L is equals to inductance, C is the capacitance per unit length. Consider a semi-infinite transmission line connecting to a finite transmission line of the direct characteristic impedance. There is the impedance of references voltage and the semi-infinite transmission lines too. Transmission line impedance load. There is the diagram there. That based upon the diagram, Z0 is equals to root of L by C. L is the inductance and C is the capacitance. Understanding Z is the essential for matching transmission lines of the minimum referential and maximum power transforms. Propagation constant. We know that propagation constant is equals to rho is equals to the propagation constant. Rho is the complex quantity that describes as equals to attentions on the phase shift and the wave travels down in the line. In this expression, as rho is equals to alpha plus j beta, alpha represents as a attenuation per a unit length, beta represents as a phase constant. Analyzing the propagation constant helps to engineers to assume a performance as a transmission lines over long lengths. Reflection of the transmission. In an infinity transmission lines, reflected occurs when is the impedance mismatch at the any junction. The reflection coefficient rho and quality the propagation of the wave reflected back to the towards the source. Proper termination of the line is a critical reduction and reflection and ensure efficient signals and transmission lines. These are applications of the infinite transmission lines. Infinite transmission lines are widely used in designing RF circuits, antennas and microwave engineering. They serve as a model of understanding of a behavior. Real transmission lines in a high frequency applications. Additionally, they are used in development of a various components such as filters and matching networks. These are the transmission line of the RF system. Please understand the diagram there. And conclusion. The theory of a infinity transmission lines providing a valuable insights into a behavior wave propagation. Analyze the line in the designing and optimize modern communication systems. Here the conclusion is the infinite transmission lines. They will be providing insights of a behavior of wave propagation. This may be understanding the wave propagation, analyzing of these lines and the aids on the designing, optimize of the modern communication systems too. Consider research and understanding of the propagation enhancing a future technology and signal transmission. These were the references of the microwave engineering Again, it comes to a field of a wave communication electronics. Again, it comes to a engineering electromagnetic. After that, electromagnetic propagation waves. Thank you.